Hi everyone, welcome back to my tech stack learning channel. I hope you all doing really great. This is my another series of LangChain, where today I'm going to cover about the website loaders. In my previous session, I had given what is document loader and what are the different types of loaders we have. So today we are going to deep dive on one of the type, that is website document loaders. And stay tuned. And if you like my channel, please go ahead and subscribe to my channel. Give it a thumbs up. And if you have any specific topic which you want to cover, please put it in the comment box. Okay. So what is website document loader, right, in LangChain? This is basically the tools that let you bring the knowledge from the website directly into your AI applications. Okay, in simple terms, you can say that they turn your raw web pages into AI readable data, right? That LLM can actually understand, right? So these loaders handles the entire process for you, right? Like starting from downloading the web pages, then extracting the meaningful text, and then removing the HTML noise like scripts, ads, and then preserving the important metadata such as URLs, titles, etc. Right. So once the website content is converted into the structured document, so it can seamlessly flow into the rest of your AI pipeline, what you are seeing here, right? Where the data is split into the chunks and then embedded using the OpenAI embeddings and then stored into the vector databases. And finally queried using the retrieval augmented generation of the RAG. Right, this process makes website document loaders a critical foundation for building any kind of applications like chatbots or AI search engines or the knowledge powered assistants, right, that actually rely on the up-to-date informations. So why these website loaders are important, right? So because websites are one of the largest and most valuable source of knowledge, right? But raw HTML on its own is not useful, right, for any LLMs. So website document loaders solve this problem by removing the scripts, ads, or the boilerplate contents, or extracting the clean and readable text, and preserving the structures and the sections and the headings, so the meaning is not lost, right? And they also make it possible to crawl and scrape the large website at scale, right, and can handle both static pages and the JavaScript based sites, right? So without website loaders, what LLM would either end up with is hallucinating answers, right, missing the critical context from the source material, or completely fail to scale up, right, when working with the LLM or the complex websites. So what a website loader produces, right? So it outputs one or more standardized document objects where the clean extracted text is stored in a page content. Okay, and important details like source URL are captured in the metadata, right? This consistent format is powerful because it allows any downstream, any LangChain components such as text splitters, retrievers, or the agents to work together seamlessly, right? So without worrying about offers about where the data came from, right? And the LangChain offers multiple types of website loaders to match the different needs, right? Static page loaders for simple HTML sites, structured content loaders that preserves headings and the list for better semantics, crawlers that recursively ingest entirely documentation sites, and sitemap based loaders that follow like site owner approved URLs, right? And the browser or API based loaders that can execute JavaScript for modern frameworks like React or the Next.js, and AI powered extractors that pull targeted structured information using an like natural language, right? In the overall AI pipeline, you see the website loader, then LangChain document splitter, embedding, and the vector databases. Right, finally into the LLM, making them the first and most critical path in any of the web-based RAG system. So when working with the website document loaders, right, there are a few things you need to consider or keep it in the mind, right? Not every loader supports JavaScript. So modern dynamic websites may require browser based on the API driven loaders, right? So large websites can easily generate thousands of documents, which impacts the memory, storage, and the embedding cost, right? Some sites actively block bots or scrappers through robot text or rate limiting, and API based loaders may introduce additional usage cost also, right? So most importantly, the loader you choose directly affects the quality and accuracy of your RAG system, so which making the right loader selection such as critical, just as the critical as choosing the right LLM, right? In summary, we can say that website loader transform the raw web pages into the LLM ready documents, enabling the uh, enabling the scalable and accurate knowledge ingestions, and it is a core building block in LangChain for creating chatbots with the AI assistants. Okay, so now let's see how does this the document loader works, right? So what I'll do here is I'm just going to create a file called website loaders.py. Then I will start with the first loader, that is web-based loader. Okay, so here I'm going to use this particular URL for our examples. Okay, so just give me a second. Let me find that URL. Just a second. I'll use this particular URL for our this one. Okay. So what I'll do here is I will start with the web-based loader to start with. So what I need here is, what is web-based loader? This is basically used for URL lib. It actually internally uses the URL lib. Beautiful. So fetches the static HTML pages and strips scripts or styles, right? And it is mainly useful for simple blogs or doc sites or static pages, not for the JS heavy websites. Okay, so I'm just importing LangChain dot document loaders, import web-based loader. Then what I'll do, web-based loader of, I'll just put this particular URL. Okay, then what I'll do here is documents equal to loader equal to, I'll just do, then I'll say loader dot load. Okay, then I'll say print of documents. Okay, let me print all the documents for this. Let's see how big it is. Okay, just wrap it. What web base loader? So yeah, you can see it has extracted all the whatever the FAQs was under this particular Google policies. It has extracted all the content, right? This is how it works. This is mainly for the simple blogs, right? So here what happens, it actually downloads the HTMLs, uses the beautiful soup to extract the text, stores URLs in the metadata. And the limitations here is JavaScripts are not executed. Some sites block, right? So that's how it is. The next we will see is unstructured URL loader. Okay. So here uses unstructured library. So extracts layout, aware text, then handles headings, tables, and list. Right. It is mainly used for docs, articles, or semi-structured pages. Right. So what I'll do here is from LangChain dot document loaders import unstructured URL loader. Then I'll say URLs is equal to is this one on the output. Okay. Then I'll have loader equal to unstructured loader of URLs equal to URLs. Then I'll have docs equal to loader dot load. Then we will have print of docs. Okay, so what I'll do here is I'll just comment this for now. Just a second. Just I'll just remove this print. Okay. So here what happens is HTML, it takes the semantic blocks, then preserves the document structure, right? And it will give you the documents there. See, it maintains the metadata and things in the proper format, right? That is how this unstructured works, right? Then we have we will have another one called a recursive loader. So this basically crawls child links recursively. It's majorly for any of the documentation sites, right? It is helpful, right? So from LangChain dot document loaders import recursive URL loader equal to recursive URL loader of, put this FAQ URL, then max depth to crawl, right? How many depth it should crawl. I'll give 2 for now. Then I'll have docs equal to loader dot load of. Then we'll have print of docs. Okay. So here it starts at the root URL and it follows the internal links and then loads each page as a document. Yeah. So it has taken that entire and it is recursively crawling and it is creating that many document, right? So you can see it's keeping on doing that. Yeah. Still doing it. This is needs rate limit for major sites, right? So it doesn't render. So you can see it has recursively taken everything, right? Okay, then comes sitemap loader. Sitemap loader is mainly uses the sitemaps, crawls only URLs defined by the sites, right? And I'll just take one example of this particular Python URL itself here for our testing. I'll just put LangChain community document loaders dot sitemap import sitemap loader. Then we have sitemap loader equal to sitemap sorry so sitemap loader dot load. Then we have print of docs. This will take a few minutes because it actually loads the stuff. I'll just print only docs of 0. Okay. So it is actually fetching the it parses the sitemap XML, then fetches each listed page and converts to a document, right? So I'm just printing only the first. If it has like 10 files, and it will 10 URLs will be mapped. So still under processing. So it will display you the one of the URLs data. Okay. So let it complete. Because in this URL it has like 168 links. You can see, right? It has given you the 168 links. So to parse that and put everything into a proper document, right? It usually takes some kind of time. So meanwhile this completes, I think we'll go for the next one, that is doclink loader, right? So doclink loader basically uses doclink parser, converts HTML to structured document, which is mainly useful for technical documentation, structured web content. Okay, so let me doc link loader. Okay, so here from LangChain doclink import, yeah, you can see it has loaded, right? For one of the URL it has for the first URL it has pulled and it has taken the content, and then it has given the metadata also, right? That is how the sitemap works. Okay, now let's see this one. I'm just going to put a comment. This one I'll put comment, don't need for now. Even this one just taking time, right? Then loaded equal to doclink loader of just use this URL again. Okay, docs loader load, we have docs. So here what happens, it applies the document aware parsing preserves sections and hierarchy, right? So which is very much good for maintaining the hierarchical related documents. Yeah, but it has all this token based maintenance, and so that it knows the connections between the documents which it has taken up, right? So the next two one is majorly if you have API keys, you can start using it. That is hyper browser uh, loader. So I can quickly take you through those code, right? You have the, I don't have the keys for now, but then if you have the keys, you can use this code this way, where import.env load the hyper browser loader using LangChain hyper browser module, and then load it, pass the keys and the URL, and you should be able to see the output, right? This basically execute JS, extract the DOMs as well, right? Similarly, there is one more called uh, agent Q loader, right? This is like query based web abstraction. So here also I don't have API keys, so I'm just showing the code how it can be used. So you can just check. I did not enable this API key yet, but yeah, this is how you can log into their agent queue site, and it's free for at least for the trial, right? You can start using it. Okay, this is majorly for agent understand the page, extract the required fields, returns the clean document. It's like a more or like a LLM driven kind of extractions, right? So this is how are the different types of loaders we have. Um, that's the end of the sessions where you have learned what is web-based loaders, what are the different types, and also you have seen the live coding examples of how to use it, right? Stay tuned for the upcoming sessions on the LangChain. If you have any specific questions, please put in the comment box. Subscribe to my channel, give it a thumbs up. Thank you.